High-energy particle physics. High-energy particle physics is a branch of physics that studies particles and how they amount to matter and radiation. The theoretical construct in particle physics is called the Standard Model, which is a theory that further explains these particles. The Standard Model contains 6 quarks, 6 leptons, 4 gauge bosons, and 1 scalar boson. These interact through 3 interactions, being strong force, weak force, and electromagnetism. A strong force is just what it sounds like. It is a force that is strong enough to hold together a nucleus against the extremely strong forces of repulsion of the protons. The strong force has a very short range. The weak force involves the exchange of the W and Z bosons, and it changes one flavor of quark into another. The weak force is crucial in the burning of the sun, as it causes the transmutation P to N, which allows deuterium to form, which then allows deuterium fission to occur. This force is also needed for the buildup of heavy nuclei. The electromagnetic force presents itself through forces found between charges and the magnetic force. It has an infinite range and is in the same form as the force of gravity. Particle accelerators help a charged particle accelerate, most often the result of a strong electric field, magnetic field, or both. Particle detectors measure the results of collisions that have been created by particle accelerators. A detector is made up of many different parts, each assigned to measure different parts of the collision taken place. Particles produced by a collision rush out of the detector, all going different directions. These particles then come across all of the subdetector layers, which are designed to measure specific particles. There are quite a few types of subdetectors, which include tracking devices, which determine the path and momentum of a particle, calorimeters, which measure the energy of a particle, and particle identification detectors, which determine the identity of a particle, also known as its mass. Particles first come across the silicon tracking system, which measures their momentum. The particles are bent into a circular path due to the fact that the detector is bathed in a uniform magnetic field. If the momentum is large, the radius of the circular path is large as well, and the path is more or less straight. If the momentum is small, then the radius of the circular path is also small, and the path is more curved. After the particles pass through the detector, they come into contact with silicon microstrip detectors, which are found at multiple points. These create tiny electrical signals as the charged particles pass by the detector elements, and the signals that are created are amplified and recorded. A sequence of signals is used to dictate the trajectory of a particle in this tracking system. A computer produces a best fit for the trajectory, which gives the track a radius, resulting in the particle's momentum. During a collision, thousands of tracks are recorded, and it looks like a big jumble of bluish lines. Now we all know a little bit more about high-energy particle physics. Thanks for watching.